Hi friends, welcome to my channel Easy Math Talks. If you not yet like, share and subscribe my channel, please like, share and subscribe my channel. Here we are going to discuss the topic is 10th class chapter 3 pair of linear equation in two variables. Here we are going to the full concept explanation. We are explained here. First one variable, second one linear equation in one variable, pair of linear equation in two variables, solution of linear equations. In that, there are two methods are there, graphical method and algebraic method. So in the algebraic method, two methods are there here, substitution method and elimination. So these are the total concepts of the pair of linear equation in two variables. We will see the first one by one. What is variable? So we know that what is variable. So the variable change its value depending on the equation is called as variable. Those are the letters and symbols. For example, so X, Y, Z, A, B, C. So these are the letters and symbols. These values are these variables are change its value depending on the equation. Those are called as a variable. Next, linear equation in one variable. Linear equation in one variable. What is the definition of linear equation in one variable? So here the equation having the degree is 1 in variable x or y, whatever that variable, only one variable. So that equation is called as linear equation in one variable. So for example, so what is the general form of the linear equation in one variable? Ax plus b is equal to 0, here a not equal to 0. So here the what here definition? So the degree, the equation of the degree is 1, having the degree is 1, then only that equation is called as a linear equation in one variable. That one variable is x. So here by using this general equation, write the example here. 2x plus 3 is equal to 0 and 5x minus 3 is equal to 0. So these are the example for the linear equation in one variable. Having the degree is 1, variable is 1. To take a suppose y minus 2. So here the variable is y. Only one variable, that is called as a linear equation in one variable. So how to find out the solution of the linear equation in one variable? How to find out the solution? See, here three examples are given, right? So what is the solution of this linear equation? 2x plus 3 is equal to 0. So just you transpose to plus 3 transpose to this side minus 3. So x is equal to transpose 2 is transpose this side 3 by 2. So this is x is equal to minus 3 by 2 is the solution of this linear equation in one variable. So here see this example. What is the solution of this linear equation one variable? 5x is equal to 3. So x is equal to 3 by 5. This is the solution of this linear equation. Okay. So what about this one? Y minus 2. Y minus 2 is equal to 0. Y is equal to minus 2 transpose to this side. Y is equal to 2. This is the solution of this linear equation in one variable. And next one, pair of linear equation in two variables. So here the equations having the degree is 1 in two variables. So those equations are called as a pair of linear equation in two variables. So what is the general form of pair of linear equation two variables? See that ax plus by plus c is equal to 0. Here a not equal to 0, b not equal to 0. So here the degree having the degree this linear equation having the degree is 1. Here the two variables. So this is called as a pair of linear equation two variables. So here example, for example, 2x plus 3y minus 5 is equal to 0. X plus 5 plus 2 is equal to 0. 3x minus 2y plus 5 is equal to 0. X by 2 plus y by 2 or y by 3 is equal to 5, and 2u minus v plus 9 is equal to 0. So these are the and etc. and so on. Okay, these are the examples. These are the examples of the pair of linear equation in two variables. See here the x and y are the two variables. Here are x and y are two variables having the degree is 1. Here also two variables, degree is 1. Here also two variables x and y, two variables. So here also two variables u, v, two variables and so on. So these are the example for the pair of linear equation two variables. So next to what is the solution? How to find out the solution of this linear equation to two variables? So how many solutions of this linear equation two variables? Here infinite many solutions are there. So the solutions of these linear equations, all linear equations are infinite many solutions. Okay. So how to find out those solutions? See, for example, take this example. 2x plus 3y minus 5 is equal to 0. So how to find out solutions? So I find out the two solutions. How to find out? Suppose if I take here x is equal to 1 or y is equal to 1. If you take either x or y, if you take any value, okay, you will get those solutions. Okay. Suppose x is equal to 1. I take x is equal to 1. Then substitute here. You will get the y value. So 2 into x means 1 plus 3 into y minus 5 is equal to 0. This is 2 plus 3y. So this minus transpose to this 5. Transpose this side plus 5. So 3y is equal to 5. This plus 2 transpose to this minus 2 is equal to 3. So y is equal to 3 by 3. That is equal to 1. So here the solution is what? X comma y. Showing the solution is x comma y. X is 1 now, y is 1. So 1 comma 1 are the solution. Okay. If you take either x or y, take any value, the real value, take that, you will get the solution. Suppose one more. Suppose x is equal to 0, I take. What is the y value? Then substitute here this equation. So 2 into x is 0, 2 into 0 plus 3 into y minus 5 is equal to 0. So how to simplify this one? 2 into 0, 0. So 3y minus 5 is equal to 0. Minus 5 transpose to this side. 3y is equal to 5. So y is equal to 5 by 3. So therefore the solution is x comma y. So x is 0, y is 5 by. So in this way you have to find out the solutions. So those solutions are infinite many solutions of this pair of linear equations. Okay. So we will see what are the methods. What are the methods that are involved in the solutions of the linear equation two variables. We will discuss one by one. See here the first one is the graphical method. Next one is the algebraic method. We will see that how to find out in the graphical method. So here there are two types of the systems are there. There are two types of systems. Two types of system. First one is consistent system. Second one is inconsistent system. Okay, so the pair of linear equation two variables having the solutions are infinite many solutions. So how to show in a graphical method? So there are two types of systems are there. First one is a consistent system. Second one is a inconsistent system. What is consistent system? So if the pair of linear equations or a simultaneous pair of linear equations having the solution at least one solution, those system is called as consistent system. At least one solution. See the first one, consistent system. What is the consistent system? If the system of simultaneous two linear equations at least one solution, one solution. So those system is called as a consistent system. So suppose or let us consider two linear equation, two variables. First suppose linear equation 1, L1 is equal to A1x B1y plus C1 is equal to 0. Suppose second linear equation A2x plus B2y plus C2 is equal to 0. This is equation 1, here equation 2. Two linear equations. So here these two linear equations, how to form the graphical representation. See here the first case 1. In case 1, so in consistent system, so these two linear equations intersecting at one point, if the condition is A1 by A2 are not equal to A B1 by B2. This condition is satisfied. This condition is satisfied. That system is called as a consistent system. So that point is intersect at one point. One point. So that point take P of x comma y. So how it is showing the graphical representation? So graphical representation. Suppose take a x-axis and y-axis. This is x-axis. This is the y-axis intersecting at origin. So here the two linear equations. Here one, this one and this one. Suppose this is line L1 and this is linear equation line here L2. So intersecting at the point P. This is the graphical representation. To find out the solution of these two linear equations, form that graphical representation is like this. Okay, so these two linear equations intersecting at one point. If the condition is, then only A1 by A2 not equal to B1 by B2. So then only that system is called as consistent system. And next case 2. Case 2. Here the two lines. So linear equation in two variables are the two lines L1 and L2. Those two lines are coincident lines. Coincident lines. Coincident lines. So then the solutions are infinite many solutions. Infinite many solutions. So then the condition, then that system, if the condition is if A1 by A2 is equal to B1 by B2 is equal to C1 by C2. This is the condition. So here the all ratios. So A1 by A2, B1 by B2, C1 by C2. Here all ratios are equal. The given two linear equations. All ratios are equal. We'll get that those solutions are infinite many solutions. Those lines are coincident lines. So that system is called as a consistent system. So here the graphical method. Graphical method. So what is your graphical method here? How it is look like here? So this is x-axis, y-axis. Here the two lines. See here, this is line 1. So here the graphical representation, the line is straight line or form the pair of linear equation. Okay. So here this is line L1. Okay. And next to this is L2. So these two lines are coincident lines. Whenever the condition is A1 by A2, B1 by B2, C1 by C2. So all ratios are equal. So those solutions are infinite, many solutions or infinite solutions. Okay. So those lines are coincident lines. So the system is a consistent system. So in the case 1 and case 2, we'll see the two examples. Two linear equations. This is L1, this is L2. Okay, these two linear equations. So those two are the system of these linear equations are it is a consistent system or not. We'll check that one. See here, first of all, you have to write the coefficients of these two linear equations. So write this is compare the linear equations. L1 is equal to a1x plus b1 by plus c1 is equal to 0. Second equation a2x plus b2y plus c2 is equal to 0. So first of all write the coefficients of these two linear equations. First a1 is equal to coefficient of x, so that is 1. b1 is equal to coefficient of y minus 2. Here c is equal to 0, that is c1 is equal to 0, there is no constant term. Here the a2 is equal to coefficient of x, that is 3. b2 is equal to coefficient of y 4 and c2 is equal to minus 20. Okay. Here see, check that one. Suppose here the a1 by a2, check that a1 by a2 ratio, that is a1 by a2 is equal to 1 by 3. b1 by b2 is equal to minus 2 by 4, minus 2 by 4. So 2 ones, 2 twos, that is equal to 1 by 2. So here the compare these two ratios, a1 by a2 here not equal to b1 by b2. So if this condition here two ratios are not equal means what? Having the solution is one solution, that is intersecting at point 1 point. So this is called as a consistent system. Consistent system. So intersect one point. Okay. So and this, see that how it is graph is. So x, y. So this is a line L1. It's a line intersecting a line L2. So this is the point P of x comma y. Okay. So this is the example 1 of this consistent system where the condition is a1 by a2 not equal to b1 by b2. So here the intersecting one point. And next to coincident lines. How it is coincident lines? You will see that example. So here the compare the two linear equations, simultaneous two linear equations. L1 is equal to a1x plus b1 by plus c1 is equal to 0. L2 is equal to a2x plus b2y plus c2 is equal to 0. So compare the coefficients. So here the a1 is equal to 2, b1 is equal to 3, c1 is equal to minus 9. Second equation, a2 is equal to 4, b2 is equal to 6, c2 is equal to minus 8. And this condition, check that one, a1 by a2 is equal to 2 by 4, 2 by 4, and b1 by b2 is equal to 3 by 6. C1 by C2 is equal to minus 9 by minus 18. So here minus minus cancel. See here the 2 ones to 2 twos, 3 ones to 3 twos, 9 ones to 9 twos. Okay. So here the check this, all ratios are equal, that is 1 by 2. So A1 by A2 is equal to B1 by B2 is equal to C1 by C2. That is value is 1 by 2, 1 by 2, 1 by 2. So this condition all ratios are equal means, so the given two lines are coincident lines. Coincident lines. coincident lines. So here the many solutions. So infinite solutions. So the solutions are infinite solutions. So the graphical representation is, so take x-axis and y-axis. So here the coincident lines means how it is showing that. So this is one line, one straight line, and another line is coincident lines. So here line with the coincident with line L1. So L1, L2. These lines are called as coincident lines having the solutions are infinite solutions. So the system is called as a consistent system. And next, inconsistent system. So if the two linear equations, so the pair of linear equations are here having there is no solution. No solution means there is no common point of the two linear equations. So those system is called as a inconsistent system. So here the no solution, no solution. So here, so the type of system is called as a inconsistency. So no solution means the given two lines L1 is equal to a1x plus b1y plus c1 is equal to 0. L2 is equal to a2x plus b2y plus c2 is equal to 0. These two lines having, there is no solution, that system is inconsistent system. But here these two lines, how it is, those lines are showing in graphical method here. Those two lines are parallel lines. Parallel lines. Parallel lines means having no common point of these two linear equations. No common point. No common point. So the graphical representation is, so how it is showing that these two lines are parallel lines. So here, so take x-axis and y-axis. So two lines. This is one line. So take another line. So L1, L2. So here these two lines having no common point. No common point. Those two lines are parallel lines. So there is no solution. So these two lines of the two linear equation, two variable system, this type of system is called as inconsistent system. What is the condition of these two lines? So if a1 by a2 is equal to b1 by b2 not equal to c1 by c2, satisfy this condition of this two linear equation, then only that system is called as inconsistent system. So that system has no solution. So those lines are parallel lines, means no common point. We'll see that an example. So these two lines, the pair of linear equation two variables, these two lines are parallel lines or not. So here the condition is a1 by a2 is equal to b1 by b2 not equal to c1 by c2. So those two lines are parallel lines. So there is no solution, no common point. That type of system is inconsistent system. So here compare the general form of the linear equations, compare the coefficients. Here a1 is equal to 1, coefficient of x, b1 is equal to 2, c1 is equal to -4, a2 is equal to 2, b2 is equal to 4, c2 is equal to -2. Just I compared the general form of linear equations. Coefficients of the coefficients. See that what is the condition here? Check that a1 by a2 is equal to 1 by 2, b1 by b2 2 by 4, c1 by c2. So here 2 ones, 2 twos. Here 1 by 2. c1 by c2 -4 by -12. Minus minus cancel. 4 ones, 4 threes. So 1 by 3. Here check these all ratios here. a1 by a2 is equal to b1 by b2. Here not equal to c1 by c2. Okay. So the given lines are The given two lines of linear equations. Okay, given two linear equations are, so there is no solution. Those lines are parallel lines. So that is graphical representation is what? Those two lines are parallel lines. There is no common point. Common point. Those two lines are parallel lines. So this condition is satisfied. So the type of system is called as a inconsistent system. In the graphical method, what you conclude here is there are two types of systems are there. Consistent system, inconsistent system. See here, the conclude this one. Consistent system. There are the two consistency here. So unique solution and infinite solutions. What is the condition? So the given two linear equations are two variables. So here the unique solution is the condition is here the two ratios are not equal. A1 by A2 not equal to B1 by B2. So here the two lines are intersecting at one point. Those two lines are called as nature of the lines is intersecting lines. That system is consistent system. Here also consistent system. So the solutions are infinite solutions. Infinite solutions. So the condition of these two linear equations is all ratios are equal. A1 by A2 is equal to B1 by B2 is equal to C1 by C2. So then only the solutions are infinite solutions. So the graphical representation is those two lines are coincident lines. This is the representation. Those two lines are called as nature of the lines is coincident lines. Okay, see this one. Last year, inconsistent system. Inconsistent system having no solution. That type of solution is inconsistent system. So here the condition is A1 by A2 is equal to B1 by B2, not equal to C1 by C2. Then only the solutions. There is no solution. So those two lines are parallel lines, means there is no common point. So those two lines are that nature is parallel lines. That system is called as a inconsistent system. So this is the briefly explained graphical method of two types, consistent and inconsistent system. Example, check graphically the pair of equations. So equation 1 and equation 2. So linear equation 1 and 2, these two lines are consistent, and so if you solve them graphically, see, find out the solutions of these two linear equations. First line, L1 is equal to x plus 3y is equal to 6. So here 3y is equal to 6 minus x. Here y is equal to 6 minus x by 3. Okay, write the table. So table of solutions. Here x, y is equal to 6 minus x by 3. Solution x comma y. Suppose I take it the x value 0, I take 0. Okay, we take any value. So 0, substitute here 0. So 6 by 3, 3 ones, 3 twos. So 0 comma 2. And next suppose I take x value 6. Substitute here 6 minus 6, 0, 0 by 3, 0. So this is 6 comma 0. Next, take the linear equation 2. So the 2x minus 3y is equal to 12. So minus 3y transpose to this side, 12 transpose to this side. 3y is equal to 2x minus 12. So y is equal to 2x minus 12 by 3. So here the table of solutions say x, y is equal to 2x minus 12 by 3. Here the solution x comma y. Here the two solutions are, see, next here the take x value, take 0. Substitute here 0. This value is total here 0. 2 into 0, 0. Minus 1 by 3. Minus 4. 3 ones to 3 fours. I take x value 3. Substitute here 2 into 3. X is 3. 6 minus 12 minus 6 by 3. 3 ones to 3 twos. So minus 2. So this point is 0 comma minus 4. This is 3 comma minus 2. So solve the graphically. Solve them graphically. So take the x-axis and y-axis. So this is y-axis, this is the x-axis. So point 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4, minus 5. Minus 1, minus 2, minus 3, minus 4. So on x-axis 1 centimeter is equal to 1 unit. On y-axis 1 centimeter is equal to 1 unit. That is the scale. So take the solutions, plot the graph 0 comma 2, x0, y2. So this is 0 comma. Next 6 comma 0, x6, y0. This is the point 6 comma 0. So join these 2 points. So the line is x plus 3y is equal to 6. Okay. So the form is straight line. Form is straight line. Next 0 comma minus 4. 0 minus 4 here. 0 minus 4. Next 3 comma minus 2. So here 3, here the minus 2. 3 comma minus 2. So join these 2 points. So that intersecting point is 6 comma 0. So this line is 2x minus 3y is equal to 1. See, observe this one. These 2 lines, pair of 2 lines. These 2 lines are intersecting at one point. That point is 6 comma 0. So here that is those 2 lines are intersecting lines. So these 2 lines are system of these 2 linear equations. That this system is called as a consistent system. So we have proved that graphically. Last concept, algebraic methods of pair of linear equation in 2 variables. In that first method, substitution method, elimination method. So here one more method is cross multiplication method is there. So in our syllabus that is eliminated cross multiplication method. So we will discuss only 2 methods, substitution and elimination method of given 2 pair of linear equations. See how to solve this method. So why we are choosing this method means, so we know that the graphical method. So that graphical method we will get that some fraction values that is not showing in the graphical method. In the graphical method that is not does not showing in the exact value. So that's why we are choosing the algebraic methods. Okay, so here the algebraic methods here getting the exact value, we will find out that given 2 linear equations. Okay, see, suppose first method, substitution method. So in our textbook here example for this one, how to simplify. So how to apply the substitution method. Suppose here 2 linear equations. So equation 2 can be written as, first consider, let us consider equation 2. Equation 2. So what is equation 2? X plus 2y is equal to 3. So x is equal to plus 2y transpose to this side. 3 minus 2y. So this is take equation 3. This equation 3 substitute in equation 1. We will get the y value. See here substitute equation 3 in equation 1. What are equation 1? 7x minus 15y is equal to 2. So here the x value is what? 7 into x is what? 3 minus 2y. Substitute here 3 minus 2y minus 15 is equal to 2. So then multiply 3. 7 3 ja 21. 7 2 ja 14y minus 15y is equal to 2. So here the 21 transpose to this side. Minus 14 minus 15 minus 29y is equal to 21 transpose to this side. 2 minus 21. So minus 29y is equal to minus 19. Minus minus cancel. Y is equal to 19 by 29. This is the y value. Okay. So this y value substitute in equation 3. We'll get x value. Substitute y is equal to 19 by 29 in equation 3. What is equation 3? X is equal to 3 minus 2y. So 3 minus 2 into 19 by 29. So then simplify 3 minus 19 to 38 by 29. So take LCM 29 LCM 29 times 29 into 3. 29 into 3. 3 9 ja 3 2 ja 6 87 minus here 1 time 38. Subtract 38. So 17 9. So here the 7 minus 3 4 49. 49 by 29. So this is x. So therefore, so the solution here x is equal to 49 by 29 and y is equal to 19 by 29. So you substitute x and y values in the given two linear equations. So those are the verified. Okay. So this is a substitution method. And next elimination method. So this is example 8 in our textbook. So the word problem, this is a word problem. So by using elimination method, solve this example. So how to solve this example? So to form a two linear equations by using this word problem. See here, what you are given ratios of income of 2% 9 is to 7 and their ratios of expenditure 4 is to 3. Each of them manages to save 2000 rupees per month. Find their monthly income. So how to get the income? See here the savings are total year saving is 2000. So how to get the savings? Income minus expenditure to get the savings. Okay. So first of all you have to take their given ratios are given. Okay. First let us incomes of two persons are 9x and 7x and also their expenditures are ratio is 4 is to 3, that is 4y and 3y respectively. Okay. So I have to write the two linear equations, form a two linear equations. So according to the given question, so each of them manages 2000 rupees. So according to the given question, see here the saving is 2000. So each person. So first person take so expenditure. See here the income minus expenditure to get the savings. 9x minus 4y is equal to saving is 2000 rupees. Take equation 1. And next second person. 7x minus 4y. Sorry, 7x minus 3y is equal to saving also here 2000. So equation 1 and 2. So this solving these two linear equations by using elimination method. How to solve? How to eliminate x or y. either x or y, you will get the another variable, that is x or y. Suppose I eliminate the x. How to eliminate? So here the coefficients 3 and 4. Take LCM of 3 and 4. Take LCM of 3 and 4 is 12. So then equations are written as, see here, multiply equation 1. So here the 12. So how to get this 12 here? The 3 and 4 are LCM is 12. You will get this 4 3 times. 4 3s are 12. So this equation multiplying with 3. And also 3 here. 3 4 times. So and 4 multiplied with equation 2. See here, first write equation 9x minus 4y is equal to 2000. This is equation, that is equation 1. So 7x minus 3y is equal to 2000. This is equation. See, LCM is 12. So here the multiplying this equation is 3. Multiplying this equation is 4. So then what will happen? 9x means here entire the terms are multiplied with 3. 3 9 ja 27x minus 3 4 ja 12y is equal to 3 2 ja 6000. Okay. Next second equation. So this is equation 3. 4 4 7 ja 28x minus 3 4 ja 12y is equal to 4 2 ja 8000. This is equation 4. So by solving equation 1 and equation 3 and 4, solving 3 and 4, so you get that 27x minus 12y is equal to 6000. 28x minus 12y is equal to 8000. Solve this one. Sign changes, minus plus minus. So minus 12y plus 12y cancel, means eliminated. So here 27 plus 27 minus 28. So minus x is equal to minus 2000. Minus minus cancel. X is equal to 2000. X equal to 2000. Next, substitute x value. Substitute x is equal to 2000 in equation. So here take the equation whatever it is. Suppose here take equation 1. Equation 1, that is equation 9x minus 4y is equal to 2000. Substitute 9 into x value 2000 minus 4y is equal to 2000. So here 9 2 ja 18,000 minus 4y is equal to 2000. So minus here 18,000 transpose to this side, or 2000 transpose this side, minus 4y transpose this side. 4y is equal to 18,000 minus 2000. Get 16,000. Y is equal to 4y is equal to 16,000. So therefore y is equal to 16,000 by 4. 4 ones, 4 fours. So that is 4,000. So y is equal to 4,000. Okay. So therefore the solutions are x equal to 2000 and y is equal to 4,000. X equal to 2000, y is equal to 4,000. So here the find out the monthly incomes. So therefore monthly incomes are so incomes are first person. So first person here 9x. So first person 9x. So 9 into x is what? 2000. So that is equal to 18,000. Okay. Next, second person. Second person is equal to what here? 7x. 7 into 2000. 7 2 ja 14,000. Okay. So these are the monthly incomes. First person is 18,000. Second person is 14,000. Okay. So this is about the elimination method. Okay. So if you really like my video, please like, share and subscribe my channel. Thank you.